Hi, this is my video number 22. Okay, in this video I'll talk on continue from the previous video. That in the previous video I've talked on comparison test 1, comparison test 2, right? Alright, so now we're going to prove that. Proof of comparison test. Comparison test. Okay, comparison test means here I'll prove comparison test 1 and comparison test 2. So let me state the theorem again. So briefly I can say if un less than or equal to vn, okay, if the bigger series Vn, because in this case Un less than Vm, so Vn is bigger than Un. So if the bigger series, so in this case Vn, the bigger series converge, then the smaller series converge, Un converge. Okay, and if for the same case here, un, still we take un, so the purpose is try to not to confuse us. We still use un less than vn. Now for the first case we consider vn converge. So in this case vn, we know the properties, then un, the one that we want to test. All right, now the second case is that we know un, now we want to test v. So now let's say un diverge, then if the smaller series diverge, then the bigger series also diverge. Okay, so this is what we're going to prove. I might do just one, so let's see how. Okay, if I think you can do it, then I will leave it to you to do it. So how to prove this? Okay, so first we let the partial sum of un, let's call that as Sn, where Sn is u1 plus u2 plus up to un. Okay, and then we consider Tn as the partial sum for the v1, v2, and so on up to vn. Okay, so the first case, this is the first case, this is the second case. Okay, so for the first case is that given, or we know the behavior of the first sequence, or the bigger sequence, which is converge. Okay, since the sequence converge, the partial sum, the limit of the partial sum exists. Yeah, let's call it as a t, as n goes to infinity. Okay, and since all terms are positive, you have v1 positive, v2 positive, and so on positive. Basically we have vn is a positive number, so this means that Tn is bounded less than the limit. Look at this, if you look at the sequence, it's like that, positive, then is bounded above. Okay, so in this case our sequence has a limit, then bounded, because boundedness due to the limit. So therefore we have Sn, which is u1 plus u2 plus un. Okay, and each of these terms is less than v1 plus v2 plus vn. Okay, and we know that this is Tn, and Tn is less than T. Less than T. Which means if Tn is less than T, so Sn less than that, so Sn also less than T. Right? Which means Sn is bounded. Yeah, Sn is bounded. So therefore, if Sn is bounded, the limit exists. Okay, the limit exists. So therefore, the bounded limit exists. Limit of Sn exists. So therefore, we have Un converge. Okay, so that's the proof of the first case. If Vn converge, then Un converge. Now for the second case, we prove the divergence. Okay, for the second case, what is the second case? If Un diverge, then Vn also diverge. So given Un diverge, so we have Un diverge, which means the limit of Sn doesn't exist. Okay, and since each term positive, since Un positive, so we have Vn is greater than Un is greater than some number S, say. Okay, because it's diverged for all n greater than some number n. Okay, so therefore we have Sn, which is U1 plus U2 plus so on up to Un. If Un diverge, okay, sorry. So take that one. If Tn, Vn plus V2 plus so on up to Vn, this is greater than U1 plus U2 plus up to Un. Okay, the summation of this is greater than S. So we can see from there T is also greater than S. So therefore T is unbounded. So therefore this series unbounded, which means Un diverge. Okay, so that's the proof for the first comparison test 1. Now we look at the proof of the second comparison test. The second comparison test say if the limit of Vn over Un is equal to some number L which is positive, then both Un and Vn converge or diverge. Then if Vn diverge, then Un diverge. Okay, if Vn converge, then Un converge. Okay, now look at this definition. To prove this proof, we have given that Vn over Un, this is the limit is exists, which is positive. Okay, which is positive. Then given any epsilon positive, we can find, we use definition in this case, we can find n positive such that the difference between those Vn Un minus L less than epsilon for all n greater than n. That's just definition. Okay, that's just definition. Now from that, we have Vn over Un minus L that less than epsilon greater than minus epsilon. Okay, so Vn less than L plus epsilon greater than L minus epsilon. Just rearrange those things. Then Vn is less than L plus epsilon, Un greater than L minus epsilon, Un. Okay? Now, from here we can see, this part here will give you one inequality, and the other one another inequality. Let's call this 1, let's call this 2. Okay, from 1 we can use the comparison test 1. Okay, if Un, the bigger series, converge, if Un converge, then Vn converge. Okay, and then from 2, this side, if Vn converge, then the bigger series converge, then Un converge. Okay, so this says that if the limit of Vn over Un gives some positive numbers, all right, then both series either both converge or both diverge. For the divergence, you can consider the same inequality. You can just state one more statement here. Okay, if just look at from 1 using again the comparison test 1. If Vn diverge, then Un diverge. From left hand side here, if Un diverge, then Vn diverge. So we have all those proof. Okay, we have proved the comparison test 1 and comparison test 2. So I think that's enough for this video. I will continue for the next video soon. Okay, bye bye.